This is Aaron Jerome with the Jerome Electronics again. We need to talk about breadboards, also known as prototyping boards. That's not what you're seeing on your screen. What you're seeing are just pieces of wood, which I guess are good, relatively good insulators, and people have used those to make circuits on. Not a completely rotten idea, but there are easier ways. So let's talk about circuit boards. The reason I'm showing this circuit board is because, when you get a prototype all put together and it works fine, that's great. But if you're designing a prototype and you solder everything in place, well, it's going to be really hard to desolder when you make a mistake. Again, this is a circuit board. Normally circuits are soldered onto a breadboard. This is a circuit board, but it's not a breadboard. Normally circuits are soldered onto a board like this, but if you make mistakes, it takes a long time to fix them because it's hard to remove the solder that holds them in place. We need a solution that can be quickly fixed. We use something called a breadboard, but you need to understand a few things about how a breadboard works. So here is a breadboard. Notice the breadboard has letters at the top, A, B, C, D, E, and on the inside, it's nothing mystical or magical. It's just these little metal clips. Metal clips that look like this. And sometimes you can actually get a breadboard that is clear. You can see through it, and you can see the little metal clips inside there. It's important to note that sometimes down the sides, we call those side rails sometimes, there can be longer clips because those side rails need to be connected from bottom to top. But generally, the internal clips, the internal holes, are connected side to side. So this is kind of how things are arranged on the inside. A breadboard is really just wires that can quick connect. That's all it is. So like I said, it's really just strips of metal that are folded just right so they make good contact with the wire. The breadboard provides a way to connect multiple wires, and the key word is temporarily. So if you get this thing to work, you probably want to take it all apart and solder the components together so the connections are more durable. Now, wires run underneath the holes in these locations. So there are groups of 5 here on this side, groups of 5 on this side, and it's like having a wire underneath all of those holes that would connect anything together that you plug into those holes. Notice they're only running side to side, not the other direction. So the side rails, they run from one end to the other, and generally we use those as sources of power and ground. These wires are parallel, they're not connected, there's no connection across the center channel either. So if you plug one wire in here, and if you plug another wire in here, now you have an electron path between the two wires. So you've really just connected those wires. So I think of it as a comparison to maybe a valve like this. Maybe this is for water, and I'm hooking it up to water and turning the water on, and I can get water out of any of the other valves. That's kind of what we're doing here, is like a 5-way connection. Okay. There are big breadboards. The one on the left is a short version style. The one on the right is twice as long. Notice how the numbers on the right and the left, let's see, the rows are numbered on the right and on the left. Across the top, there are letters that indicate columns. And remember, in the numbered rows and columns, the wires run beneath, they run sideways from side to side, not up and down. I've rotated this breadboard, so now they run side to side. This means that electrons will not flow in those little 5-hole groupings. Electrons will not flow if you connect a wire above another wire. They must be side by side to be connected together. Notice that on the outer sides of each board there are also what seems to be groups of 5 on the small board. but they run vertically up and down. They actually run from top to bottom. Each of the vertical columns on the outside edges are continuous connections from the top to the bottom. It's a little bit like Battleship. I think this picture cracks me up because the guys are playing and the girls are in doing women's work. And you know, maybe it's not a sexist, but it is like 70s, so maybe it is. I don't know. When these guys are done playing, I'm sure they're going to install a new dishwasher, but they can't do that right now because the women want to finish the dishes first. I guess that's a good thing, I guess. Okay, so anyway, breadboards are a little bit like Battleship, or maybe they're a little bit like spreadsheets. You can actually indicate the exact location and of each of the holes. And of course, if you played Battleship, that's basically the whole idea behind Battleship is when you attack an opponent's position, you give them the coordinates of the attack. Sorry. And so if you need to tell someone where they should make a connection, you can actually give them the address, such as, see if you can find this one. Can you find C20 on this board? So each hole has a location, right? Of course, if you're not familiar with Battleship, it is a little bit like using a spreadsheet and referring to a cell by its address. In this game, in a breadboard game, you don't plug in ships, but you plug in more interesting things like electrical components. So it is a bit like Battleship. Now, to use a breadboard, we're going to need a switch. Now, in our use, the most common switch is called an SPDT, single pole double throw. I should have made SPDT a red word. You should record this, the name of this switch, in your logbook, SPDT, because when we actually go to the simulator to build circuits, we're going to be talking about using SPDTs. SPDT, single pole double throw, is a specific kind of a switch. It's a kind of switch that you can slide it back and forth. And when you slide it back and forth, really on the inside, what it's doing is connecting wires that, are reaching up to it. That middle wire is not a double wire. It's just, I guess, extra thick. In any case, the middle wire is its own wire. Now, what happens is when you connect this side, we're calling the wire on the left a signal, an input signal, and the middle one is an output signal. And let's just say that we are connecting a voltage to the wire on the left. And when we connect them, that voltage, that pressurization in the line, remember the garden hose, stepping on the garden hose, you know it's pressurized if it's rigid, and you know it's non-pressurized. And when the pressure is, or when there's no water in it. And that's kind of the same thing we're talking about here. So when we flip the switch to the left, it pressurizes the middle data switch. Okay. And if we go to the right, this could be a power switch, but it could also be a ground switch. And that's what's really important about this switch, is that if we leave a line pressurized, even though we flip the switch, if we don't drain the line, then we might, the components, the gates, which we'll talk about later, the components will be left pressurized and give a false reading. So we generally hook one side up to power and the other side to ground. And so the power, when we flip it to the left, we'll say that's power for now, that'll pressurize the middle data line. And if we switch it to the right, that will depressurize the middle line. So hopefully that makes sense. This is just a top view of what we're talking about. What I want to do is switch it back and forth like that. Okay, so plugging a component into a breadboard is a way to multiply the connection points for that component, and then you can use wires to connect different components to each other. This switch can be plugged into a breadboard and then connected to other wires without soldering. That's kind of the point, okay? So anyway, here's a breadboard, and I'm going to use the breadboard to make a quick circuit. So we're going to need a source of power, so I'm going to use a Nuki bat for that. And I'm going to hook one side of the Nuki bat to the side rail, and we're going to call this the red rail. And this means that underneath this red rail, since the side rails go all the way from one end to the other, it's going to actually make potential sources of power all the way up and down this rail. We could actually make a bridge wire that bridges over the top to the other side and then run a wire underneath all the way up and down on the other side as well. That means any of the red plus positive side rail lines can be plugged into if we need a source of power. Now we can do the same thing with the ground side, the other side of the battery, the negative side of the battery. And of course, when we plug into the side rail, we're calling this kind of the blue side rail or the negative side, it connects from top to bottom. If we put a wire that bridges across to the other side, it will also make all of those holes potential sources of ground. What I'm doing now is plugging in one of those switches that I just showed you, and I'm hooking it up so the top of the switch, one side of the switch, gets a connection to power. Connecting the switch also so the other side of the switch gets a connection to ground. Remember, when we flip the switch to the right, it drains the middle switch, and when we switch it to the left, it pressurizes the little switch. Now, this, of course, all has to do with whether or not the plus side is where the electrons come from or not. But still, there is pressure there, because if it's not a source of electrons, it's a source of the holes. Either way, it's a source of pressure. We'll be talking about that more later. I'm going to put another switch in, connect it to power on one side and ground to the other side as well. And then I'm going to, I don't think I've talked very much about this yet in this class, but I'm going to connect a IC, an integrated circuit, also known as a chip, to the breadboard. Now, this chip happens to be a 74LS08. The only numbers we care about are the 08, and that tells us that this is an AND chip. And we'll get into all of what different type of chips you need to know, integrated circuits you need to know, and what each kind does. But for now, I'll just tell you that the AND chip has 4 AND gates in it, and each AND gate basically multiplies. We'll talk about that a little more later. These are the little AND gates inside the AND integrated circuit, or the AND chip. And I'm now going to hook up the middle data line to one of the input pins of one of the AND gates. Now I'm also hooking up the other data output line to one of the other input pins of the AND gate. Now, if we're going to call the top of the battery the red line, those are sources of ones. Let's just say those are sources of ones, okay? And the green lines are sources of zeros. Greens are ground, they're zeros, they drain the line. And ones are, in this case, we're going to call those the red lines, and they are going to power, okay? Now, what we're doing then is we're going to use that little AND gate in there, that little green D-looking thing, to multiply. Of course, in electronics, we only use ones and zeros, so that thing is going to be able to multiply either 0 times 0, 0 times 1, 1 times 0, or 1 times 1. Now, chips also need to be powered, and it's generally pin 14 that takes power, because they don't generate power. If they did generate power, we could solve the world's electricity problems, but each side also has to be grounded. It's, like a toaster, vacuum cleaner, light bulb. They have to have power and ground themselves, too, to be able to do their work. Also, we're going to use an LED to indicate whether or not our result is a 0 or a 1, because, 0 times 0 is 0, and 1 times 0 is 0, and 0 times 1 is 1, and 1 times 1 is 1. So the only way this light's going to come on is if it's connected correctly, this LED, and if this gate in this chip gets both ones, reds, into its inputs. So we need to hook it up. We're going to take the output of that little gate, and we're going to put a wire in the board that will connect the output. Now notice it connects underneath the board, and then we take a wire and bridge over to the LED. Once we've bridged to the LED, then the electrons can go into the LED and turn it on, jump over to the other side, and LEDs use less voltage. They need somewhere around 2.5 volts, whereas the chip uses 5. So what we're doing now is we're using a resistor, and that resistor can go on either side of that LED, but we're putting it over on the right side. And to reduce the amount of voltage that the LED gets, we're going to hook the LED to a resistor. And of course, the other side of the LED, we're going to hook to ground. So now we have this circuit completely connected. We can start flipping switches, and we're flipping the first switch, and that opens up the pressurized line, and it's pressurizing the first pin, the input pin of that AND gate. If we flip the switch the other way, it drains the line, and so either way, the light didn't come on because 1 times 0 is 0, and 0 times 0 is always 0. Okay. We can do that with the other line as well. That means we're pressurizing the line of the other input into the AND gate. And of course, that is also 0 times 1, and 0 times 1 is also 0, so the LED doesn't light up. If we want the LED to light up, we're going to have to pressurize both of the wires, and that sends a 1, because 1 times 1 is 1, and that goes in and it lights up the LED and makes it bigger too. That's all true except for the part about makes it bigger too. It just lights it up. And then of course the electrons are allowed to return back to the battery by going through the resistor into the ground, which goes back to the battery. Therefore, it is a complete circuit. Okay, that is a simple circuit. That's one of the first circuits we're going to make. And I just want to show this. The lower left circuit won't work because both of the inputs of that LED are connected to the same wire, and so there's no place for the electrons to go. So when you're hooking up LEDs, you kind of have to go from a bottom row to power and then top row to ground or something like that. Just want to make sure you understand that that is how they are connected. Also, that LED there that's lit up, it is a polarized component, which means that if you put it in backwards, it doesn't work. So one reason why your circuit might not work is either that LED's been given too much voltage and it's burned it out, or it's in backwards. So one thing you can do to check it is to turn it around. Now there are ways to tell, but I'm going to talk about those later. Ways to tell, well, you know what? You can kind of see it. Maybe I'll talk about it now. On this LED, you can see right here, this side is flatter than this side. Okay. The flat side is always next to the ground pin. So this pin should always be hooked eventually to ground, whereas this one, notice it kind of bows out like this, and that means that is the positive side. That's the side that always goes to positive. Now, also, when you get these LEDs, one of these legs could be longer than the other. The long one is generally the negative leg, but those generally get cut off when they're soldered in, so they're not always something you can use. But this little flat spot right here on LEDs, we'll look at more later. That's how you know the negative side of the LED. Okay, enough of this for now. We'll talk more later. Thank you for listening, and we'll see you next time.